Hello everyone, this is Shalom Siddiqui and today we have new topic. Today we will discuss about the bending moment and shear force diagram for simply supported beam. Simply supported beam, you all very well know about the simply supported beam is the beam which are supported at the two ends, one and the other end, and the middle, the span is lies between the two supports is known as simply supported beam. So today we have one numerical problem on simply supported beam and we will discuss about the shear force and bending moment diagram for simply supported beam. As you all know that there are, as our previous lecture we discussed about cantilever beam for shear force and bending moment diagram, and in that particular question there is a different type of load which are applied on particular beams, cantilever beam. One is point load and other is UDL, uniformly distributed load. And today we will discuss about the simply supported beam, and in that there are two type of load which are applied on a particular span. There is one load, there is a point load which are applied at 6 kilonewton at a distance of 2 from B point. You can write the name of C and this is point D. So there is a B to C is 2 meter and the applied load is 6 kilonewton as a point load, and from here A to B is 3 kilonewton and the distance is between 2 meter. So the overall distance or overall the length of the beam is 6 meter. So first we will calculate the moment reaction, shear force diagram calculation and bending moment calculation, and after this we will draw the diagram for shear force and bending moment. So we will start from moment reaction. Put MA is 0. The moment at point A is 0. So we will going from B to A. All of you know about that. You can realize and you can mention one thing, that when you will go from the anti-clockwise direction, in anti-clockwise direction you will put the sign as negative. So when we go for anti-clockwise direction, all these values, there is support or the load or the couple, there is a moment, so we will take negative sign, and the load or the support we will go from clockwise direction. The clockwise direction you will take the positive sign. So this is a B. The B is going for point A is negative direction, means anti-clockwise direction. So the moment will apply from bending moment, the load into perpendicular distance equals to moment. So put A equals to 0, moment at point A equals to 0, so minus RB into, this is the load or the, you can say support, the load and the perpendicular distance from B to A is 6 meter. Okay, now come to point C. The point C is 6 kilonewton and going like clockwise direction. In clockwise direction put positive sign, so load into perpendicular distance is 2 plus 2 4, so plus 6 into 4. Then come at point D. This load is 3 kilonewton and going for clockwise direction, so put the sign is positive, so the load is 3 and the distance is 2 equals to 0. We have one unknown, this is RB, so from here we will calculate the value of RB. So RB into 6 equals to, first calculate this value, this is 24 plus 6 equals to 0, so 6 into RB equals to, put these value from this side, so it will take positive sign, so this is 30, so RB equals to 5 kilonewton. We have the value of RB is 5 kilonewton, so RB is 5 kilonewton. Now as discussed about previous lecture, I discussed that when you will calculate one value for RB or RA, so the value for calculation for different another value for put RA plus RB equals to total load which are applied on a particular span. So the load is 6 plus 3 is 9. So the put the value for RB is plus 5 equals to 9. So RA equals to 9 minus 5 equals to RA equals to 4 kilonewton. So from here we calculated the value for RA and RB. So RA value is 4 kilonewton. Now from here, now we will calculate the shear force value. The shear force value, that we have 4 points. Point number A, point D, point C and point B. We calculated 2 values. We have calculated 2 values. One is A point and B point. So the value for A is 4 kilonewton and the value for B is 5 kilonewton. Now we have only 2 values for calculating. So point D and point C. So how to calculate the value for shear force at point B? So this is a force 4 kilonewton going for clockwise direction, positive, and this is a clockwise direction, and this is 3 from going for downward direction. Don't confuse about that. When the sign is going for upward for shear force, I am discussing about the shear force diagram only. When you calculate the shear force value, so when the load or the support going for upward, take positive sign, and the load is going for downward, take negative sign. As simple as that. So 4 minus 3 equals to 1 kilonewton. Now point C. So 4 is going for upward. 4 minus 3, because the 3 is load is for downward and 6 is for downward is 6. So calculated 9 is minus 5 kilonewton. Now these are the values for shear force diagram. Now calculation for bending moment diagram. Value for bending moment. The value for bending moment, you all know that we have 4 points A, point D, point C and point B. I am going to tell about that when you will draw the shear force or bending moment diagram for simply supported beam. This is for bending moment diagram, the simply supported beam. So the bending moment for simply supported beam from end points, means there is a support from point A and point B, always keep it as 0. Okay, so this is a 0. Because the point B and point A, it will not apply a load any particular point, because the load which are applied on the span is at the middle point or somewhere else in the span. So when it applied, so the bend for downward direction. So put A equals to 0 and B equals to 0. Now we have point D and C. So from one point we will calculate it from D, and from one point we will calculate it from C. So first we will calculate for point B is 4 multiplied by 2 is equal to 4 by 2 is 8 kilonewton meter, because the bending moment is load into distance equals to bending moment. So the value for D is 4 multiplied by 2 equals to 8 kilonewton meter. Now for value C. So we will start from point B. So point is 5, because it is going from upward, and 5 multiplied by 2 equals to 10 kilonewton meter. So value for C is 10 kilonewton meter, and the value for D is 8 kilonewton meter. Now we have moments value, we have shear force value, we have bending moment value. Now we will draw for bending moment or shear force diagram. Now this is the span. First we will draw shear force diagram. So this is point A, this is point D, this is point C and this is point B. So at point B the load shear force is 4 kilonewton, but it is positive, so it will go for upward, and there is no load between A to D, so we will go for like that as a constant. Now at point D, there is a value for 1 kilonewton, and the 1 kilonewton is less than the 4. So we will go for downward. Because this is a 0. The line is axis is 0. Form start from 0. So now from D to C, there is a no load, so it will go for constant, or you can say that linear. Now point C, the point C value is -5. The value for -5, this is a 0. Now this is 0 going for minus, so this is a, you can say that minus and there is no load between C and B, so going for constantly. Now the value for B is 5 kN, so this is a -5, we will go for upward, this is a positive 5. So now this is the bending shear force diagram for simply supported beam with a point load. Put all these values. This is a 4 kN, this is 1 kN, this is -5 kN, and this is 5 kN. Now we will draw the bending moment diagram. Bending moment diagram, you can say that from here I will draw. This is point A, this is point B, this is point D, and this is point C. So the bending moment diagram, point A and point B is 0, and the value for D and C is positive, so we'll go for upward direction. And I discussed about the previous lecture that when we draw the bending moment diagram for the point load, you will go for like slope y direction. So go for slope y direction, and this is for slope y direction going, and this is the bending moment because both the values are same. So this is the bending moment diagram for simply supported beam. Put all these values. This is 0, this is 8 kN, and this is 10 kN. This is the highest point of the bending moment. This is reflection at point. You can say that this is the X point. This is the highest of the maximum point for bending moment diagram. Now from this lecture we discuss about the simply supported beam for how to calculate the bending moment values, shear force values, and the moment values, and how to draw the shear force diagram and the bending moment diagram. Hope I understand that. Hope you will guys understand what I have taught about this lecture. And if anyone has doubt, any queries regarding this topic, regarding this question, please mention your comment in your comment box, and I will discuss your question in the comment box also. And please like this video, subscribe this video, and like the channel of this, and go through as also previous lecture that I have shared about you. And if I will say again and again, if anyone has any type of doubt, please